In this video, we're going to continue looking at the idea of tails and error in estimates. And just to kind of set the notation, what I want to remind you of is that we know that if we've got an infinite series, we can write that infinite series as the nth partial sum plus the tail. And the tail here is just the infinite series as k goes from n plus 1 out to infinity of the AKs. We can do the same kind of thing for improper integrals. If we start with an improper integral from 1 to infinity of f of x dx, we can write that as a proper integral, a proper definite integral, plus the tail, and the tail here is just the improper integral from n out to infinity of f of x dx. Now, what we want to look at in this particular video is the idea of what if we use Sn to approximate the whole infinite series, or what if we use the definite integral between 1 and n of f of x dx to approximate the whole improper integral. How good is our estimate? Well, that's not actually a difficult thing to, let's write that where people can read it. This is not a difficult question to actually answer, so let's look a little bit at how we might answer it. Well, it turns out that if we use Sn to approximate the infinite series, then the error in our approximation is actually equal to the tail of the series. And likewise, if we use the tail of if we use the definite integral from 1 to n of f of x dx to approximate the improper integral, then the error, again, is just the tail of the series. Now, the importance of this idea is the following. If we can somehow show that the tail of a series or an improper integral is less than some small number that I am going to call epsilon, so epsilon here is a small number that's bigger than 0. If I know that the tail of a series is less than epsilon, or the tail of an improper integral is less than epsilon, then what I know is that the error in using Sn to approximate the whole series, that error is less than epsilon units. And if I'm looking at tails of improper integrals, the error in using the definite integral between 1 and n of f of x dx to approximate the improper integral, the error here is also going to be less than epsilon units. Now, it turns out that this is an important idea because what this lets us do is it lets us ask this kind of a question. If we want to build an estimate, for either an infinite series or an improper integral that is accurate to epsilon units, all we have to do is we need to find a capital N such that the tail of the series or the tail of the improper integral is less than epsilon units. Because if that tail for capital N is less than epsilon units, then the partial sum as capital N, so the sum of the first n terms, and the proper integral between 1 and capital N, these two estimates are good enough. And finally, I kind of want to also remind you about one other thing dealing with errors. If we want an estimate to be accurate to, let's call it L decimal places, then what we need is that the error has to be less than, and technically this is the absolute value of the error, but the error has to be less than 5 times 10 to the minus k minus 1. That's 5 times 10 to the minus parenthesis k plus 1. And just to kind of illustrate what this means, if I want 2 decimals of accuracy, 2 decimals of accuracy, then I want the error to be less than 5 times 10 to the minus 3, and that would mean I want my error to be less than 0.005. If my error is less than 0.005, then it turns out that the estimate and the actual number will round to the same thing if I round to 2 places. And that will be true because the error itself, if I round to 2 places, any error that is less than 0.005 will round to 0.00. So just as a quick little example over here, if my error were 0.0043, when I round that to 2 decimal places, that's 0.00. But if my error is something like 0.0054, when I round that to 2 decimal places, that's not quite small enough because to 2 decimal places, that winds up being 0.01. In the next video, we're actually going to start getting our hands on how do we look at specific tails and look at specific how far out do you have to go ideas.